Okay, so our nonlinear systems basically means at least one of the two equations are not linear, not a line. A lot of times that'll look like a parabola. Essentially what I'm asking you to do is the same things I've been asking you to do in the past. Only we're putting them together. So for this first one right here, my slope is 2, my y-intercept is 3. And I'm going to graph that. I know you can see some of the numbers already. That's okay. Y-intercept is 3. My slope is 2. So I'm going up 2 over 1, up 2 over 1, up 2 over 1, and then down 2, left 1. Make that a little neater there. Down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. I know the answers are in front of us, so it kind of takes the surprise away. But when I grab this, I find my vertex. Negative b over 2a. Negative b over 2a is negative 8 over 2 times negative 2, which is 2. A positive 2. That's the x-coordinate of my vertex. Negative 2 times 2 squared plus 8 times 2 plus 3. Well, 2 squared is 4 times negative 2 is negative 8. Negative 8 plus 16 is 8, and 8 plus 3 is 11. My vertex is 211. Now here, obviously, I got to go slightly off the graph. On a test, I would probably try and keep it on the graph the whole time. Okay, but for here, I don't think it's a big deal. You have to kind of guess and check a little bit there. And then I get 2 points. If I plug 0 in for x, I get 0, 3, and 4, 3. What's nice here is this. 0, 3 actually gives me an intersecting point. And then 4, 3 is my other point. If you think about it, this parabola is going up and down. What is a likely point it's going to also intersect that? I would argue right here. I would check that. What happens if I put x or 3 in for x here? Well, negative 2 times 3 squared plus 8 times 3 plus 3. 3 squared is 9 times negative 2 is negative 18 plus 24 plus 3. That equals 9. So we know 0.39 is also a true statement here. Check out where 39 is. And that's enough where I draw my parabola. And then I just draw my line in. But by doing it that way, it really accentuates the points of intersection. Sometimes you'll have 2, sometimes you'll have 1. In this case, your answer is 3, 9 and 0, 3. The 2 points of intersection. Okay. All right, algebraically, we're going to do it by substitution. Since y equals 2x plus 3 and y equals negative 2x plus 8x plus 3, two things equal the same thing, they also have to equal each other. Okay? So that way I can set them equal to each other. Now the rule of thumb is this. Whenever you have an x and an x squared in a problem that you can't eliminate either one of them, you have to get them all equal, or all to one side, equal to 0. If you have x and x squared, you have to set up a factoring. If you noticed here, I added 2x squared to the other side. That's why I have 2x squared. I subtracted 8x to the other side, so that way I have negative 6x. And I subtract 3 on both sides. You really want to get it so your x squared is positive. That's why I moved this negative 2x squared over to the other side. Okay. Anytime you get the x squared positive, it's to your advantage. Now I'm left with 2x squared minus 6x. That's basic factoring. Take a 2x out. You're left with x minus 3. And then 2x equals 0, my x equals 0, or my y equals 3. Now, in a problem like this, once I find my x, I've plug it back into one of my two originals to get my y. It's clearly easier to plug it into this. So, when x is 0, 2 times 0 is 0. 0 plus 3 is 3. So when x is 0, y is 3. That's one of my answers. And you can write that as 0, 3. And now I have my second x of 3. Got to plug that one in. 2 times 3 is 3. Wow, I misspoke there. 2 times 3 is actually 6. Plus 3 is 9. So my other answer is going to be 3, 9. I'm going to do the parabola first in this case. So that's a negative b over 2a, and I like to write the negative b over 2a out first. All right. So that's going to be negative 2 times 1. So the x-coordinate of my vertex is going to be negative 1. To get the y-coordinate, it's going to be negative 1 squared plus 2 times negative 1 minus 8. 1 minus 2 minus 8 is negative 9. So that's my vertex. Negative 1, negative 9. And I'm going to put that in right away. Clearly 0, negative 8 has to be a point. And therefore 0, negative 8 has to be a point. So it is negative 2, negative 8. My parabola's got to be symmetric. Now, what I would do if I were you is, you got to be careful just drawing a rough sketch. All right, because in this case we are looking for an exact point of intersection. So to help me out with that, what I might do is this. I might start with my 2x plus 1. So I bring that down here, my slope of 2 and my y-intercept of 1. My y-intercept is 1. My slope is 2, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And now I'm also going to go down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. Now my argument would be be smart about this. Okay? My parabola is going to go like this. So to me, that looks like a point that's potentially a point of intersection. My x is negative 3 at it. If I plug negative 3 into my x squared here, or into my x squared minus 2x plus 8, or is it x squared plus 2x minus 8, excuse me. Negative 3 squared is 2 times negative 3 minus 8. Let's watch what happens. We get 9 minus 6 minus 8. Okay. 9 minus 6 is 3. 3 minus 8 is negative 5. So point negative 8, 5, or don't put it in the wrong order. Point negative 3, negative 5 is a point on that parabola. 1, 2, 3, 1, 2, 3, 4. Hey, how about that? Now, going the other direction, I'm looking at this as a rough sketch. I'm thinking the point 2 might hit. Okay? It's certainly not going to hit at 0, 1 because I'm still down here. Okay? But if I were to put 2 in for x, let's see what happens. 2 squared plus 2 times 2 minus 8. We get 4 plus 4 minus 8, and that's 0. So 2, 0 is a point on my graph. Well, that doesn't intersect anything, does it? So here's what we have to do. Okay? It's crazy. Right? If the first one I tried didn't work, what do you think I need to do? Try another one. Yeah. It's not, oh, gee whiz, the first one I guessed didn't work. I'm done. No. Okay? This line keeps going up. The parabola's going to keep going up. Let's try 3. See what happens when a 3 goes in here. 3 squared plus 2 times 3 minus 8. 9 plus 6 minus 8. 15 minus 8 is 7. So that means 0.37 is also on this parabola. Let's take a look at where 3, 7 is on the graph. 1, 2, 3, 1, 2, 3, 4, 5, 6. Hey, how about that? And if I want to make a neat graph, here's my vertex. I went over 4 points to get to the 3. 1, 2, 3, 4. That'll help my drawing out a little bit. We can draw the vertex in. I would also, in the end, draw the line in. So these are my 2 points of intersection. 3, 7. 1, 2, negative 3. 1, 2, 3, 4, 5. Negative 3, negative 5. And those are my 2 answers. Yes, Max? Now, if I want to do this algebraically, it's simply 2x plus 1 equals x squared plus 2x minus 8. Since the x squared is positive here, I'm going to move the 2x and the 1 over. 0 equals x squared minus 9. So when I factor that, it's x minus 3x plus 3. So therefore, my answer is x minus 3 equals 0, x plus 3 equals 0. My x answers are 3 and negative 3. And I'm just going to plug that into an original. 2 times 3 is 6 plus 1 is 7. 3, 7 is 1 point. 2 times negative 3 is negative 6 plus 1 is negative 5. Negative 3, negative 5 is the other point. Those are my 2 answers.